Okay, guys, part C. Find the x-coordinate, and there's a lot of words here, guys. It tends to wear you down a little bit, so you just got to, be a little bit patient. Find the x-coordinate of each point at which the graph of G, okay, so they're talking about the graph of G. I don't have a graph of G. I got a graph of F. So I have a graph of G prime of x, which equals f of x. That's the graph I have, okay? I don't have a graph of G, but they're asking me about the graph of G. So what they're saying is find the x values. Find the x values where the graph of G has a horizontal tangent line. What do we know about horizontal tangent lines? What's the slope of a horizontal tangent line? For a horizontal tangent line, G prime of x equals 0. So G prime of x equals 0, where f of x equals 0, which is when x equals, so where's the f function equals 0? There and there. So when x equals -1 and 1. Okay? All right. And then it wants to know, is it a max, a min, or what? So that's kind of the first part. Okay, the second part, when x equals -1, f of x goes from positive to negative. Therefore, the slope of g of x goes from positive to negative. Therefore, g of x has, so if the slope was positive, it was going up, slope was going up, now it's coming down, has a relative max at x equals -1. Okay? When x equals 1, f of x, and therefore g prime of x, do not change sign. If you look, it was negative, went to 0, it stayed negative, didn't change sign. Like over here, you went positive to negative, so that was a max, didn't change sign. When x equals 1, f of x, and therefore g prime of x do not change sign. Therefore, at x equals 1, there is neither a max or a min. That's it. Guys, this is a pretty well-balanced problem. The first part, A, was worth 2 points to find G and G -2. The second part, B, was worth 2 points to find G prime and G double prime and -3. This part is worth 3 points. And then the last part, D, is worth 2 points. So let me hit D now. Okay, so part D. So between -4 and 3, and that's where the whole graph is. The graph starts at -4 and it ends at 3. So for -4 to 3, find all values for which the graph of G has a point of inflection. So guys, if you remember, points explain your reasoning. Okay. If G has a point of inflection, that means G double prime x changes sign. That's points of inflection. If the second derivative changes sign, you got a point of inflection. So let's go back here. Okay. 4 points of inflection, G double prime x should change sign. g double prime x is f prime of x, which is the slope of f of x. Therefore, points of inflection occur where f of x, where, I'm going to say the slope, where the slope of f of x changes sign. F of x, slope. Slope of f of x changes sign at x equals, okay, so let's look. Here we go. I'm going positive, negative. It happens there. X equals -2. Coming down. Boom. It changed. I was going down, now I'm going up. So x equals 0. I'm going up. Boom. My slope changes there. Okay, so it happens at 3 places. X equals -2, 0, and 1. That's the answer. That's the final 2 points. So they give you 1 point to find these 3 values, 1 point to talk about why, you know, how it's the second derivative changes sign. So that's it, guys. That's a 2012 nice balanced problem.